Today I'm going to use this demo app to demonstrate how you are going to write a Flask application that is able to serve a website, and this website is able to interact with the MySQL database on the GCP. And finally, how do you deploy the entire application onto GCP? So first off, I am going to do a quick demo to show you the CRUD operations that this application can do. So I could add a new task. This would be sent to the database and stored inside the database. This view itself is a read operator, so it shows everything in the database as of right now. The update feature, we could change the content as well as the status of a task. And finally, we could delete whatever we want. All right, so without further ado, let's begin a coding walkthrough for this application. All right, let's get started by creating a folder. Right now I have a folder called demo. In this folder, the first thing that I will do is to create a virtual environment. This virtual environment allows me to install things encapsulated within this project, and I'm going to establish and enable this virtual environment. So once I have this enabled, I am going to pip install all the libraries that I'll be using throughout this project. Now the installation has been completed. Now I'm going to create some of the files and file structures that I'll be using in this application. So the first thing that I will do is I'll be creating an app folder, but also a main.py. So the main.py basically acts as a entry point that I would be able to source the app. Inside the app folder would be all the meat. So where the app, everything that's going to happen here. And the first thing that I'm going to create is a init.py. And so this init.py will be run every time the app gets spun up. And so since we have this, I am going to import app from the app folder. And so inside the init, we will be creating an app shortly. So this is from app, which is this app folder, import app, a object that we'll be creating shortly. So let us create the app right now. So in order to create this app, I am going to first call in Flask. So from Flask, import Flask. And creating the app will be as simple as app equals Flask __ name __. And this would be the simplest application we could have. By this, we won't be able to see anything. So what I'm going to do now is I'm going to pause the video for a bit and then write a very short snippet of what the basic Flask application looks like. Okay, I am back. So you can see that right now I have added 3 more lines of code and I imported JSONify. So what this basically does is it tells Flask that, hey, whenever there is a request that wants to go to this location of the application, please call this definition function, which is what I called homepage, and this homepage should return status okay. So how do we verify that it works? So in the terminal, I am going to first tell Flask about this application. So I'm going to say export Flask app, and notice here Flask app basically is the app living here in this app folder. So I'm just going to say this Flask app is called app. And I am going to also tell Flask that I am currently in debug mode so that it gives us special help when we actually do Flask run. So notice that because this is under Flask debug 1, whenever I change something and save it, you'll see that it's actually reloading the changes, which is really convenient. So right now, let me pull up a browser. All right, so right now, let me just make this smaller. You can see that on localhost 5000, which is where this server is running, you see this JSON file status okay, which is what we're returning. So yes, the server is running great and we have everything. So next up, we want to show how do we actually return not a status, but actually a interface. So actually a HTML file, HTML with CSS with JavaScript. And let me pull in some additional files and again, I'll be right back. All right, Right now, the things that I changed is basically under the app folder, I have added an additional folder called the templates. Inside the templates folder, I made a index.html that simply says hello Bob. Remember before here we have the JSONify string. Right now what I did is instead of that, I changed it to render template. So let's just see what is going to happen by refreshing the page real quick. It'll say hello Bob. So what it does is it actually, instead of passing the string, it's passing this index.html. And by default, what Flask does is it looks for this file under the templates folder. So it is really important to name your templates folder templates unless you want to change the default value. So we don't want to just serve an HTML. We want it to change as data change. So what I'm going to do here is I'm going to add 2 brackets and change this into name. So this 2 brackets basically tells Flask that, hey, right now I'm writing not only HTML, but what it calls a Jinja templating engine. So the Jinja templating engine will see 2 brackets as a variable, and it's going to say, okay, now tell me what the name is. So I could say, maybe let's put the name N, for example. And let us refresh the page. You will notice that the page has changed. And the reason behind that is because as a templating engine, what it's trying to do is before sending the actual index.html back to the user, back to the client, it's going to look for double brackets and other kind of logic inside this HTML and replace it with whatever you define. It renders the entire template and sends the updated index.html back to the client. So this is how the concept of how Flask works. And right now I'm going to complete the rest of the project, the rest of the application. Again, I will be right back to show you the next part. So notice that I have added some additional files, namely a database.py file and the routes.py file. You'll also notice that in my init.py file, I've removed the routing information because I've moved it to routes. So I am going to separate these just so that it's easier to navigate and also cleaner when the application grows. So what I'm doing right now over at init.py here on line 7 is to say, hey, I'm going to have routes in this application. Notice here that I also imported databases DB helper in the code. And what this DB helper does is it's going to act as like where we fetch all our data. And I'm just going to write some function that returns some information and then put this information as a variable of the name, which I had not changed, and then serve this. So when we go back to the web page and then refresh it, you will notice that the page changes because this is where it's feeding its data. So this is the basic concept of setting up a Flask that updates the view based on the given data. Knowing these information, I am going to update the code so that it looks very similar to our to-do list app before we connect it to our MySQL database. So let me go through what I have changed. Notice that I've added quite a number of files here, but don't worry, let's walk them through. So the first change is to the index.html. Basically, I have written the entire HTML file as the way that you see it look like. I've also added other files over here. So this image file is the favicon, which is not important. We also included custom CSS. And last but not least, we also added the model.js file. So I am going to quickly walk over what the different part of the model.js is doing. The only important part as of right now would be this Ajax statement that I will cover shortly. The first part of this JavaScript basically regulates all the models, which is this pop-up window that you see about, say, auto-filling the text over here or changing the title over here. The second part of this model is the submit task model, which is basically this, what happens when you click this button. Feel free to look up Ajax in greater detail, but the key point here is it tells the front end what to do, the browser, what to do when you click on the Save Change button, it fires a post request. And it looks for a URL. This URL is either an edit URL or create URL. And the reason because we're sharing the same model for the edit button and also the add task button. So there is two different URLs that the post request should send its information to. The data is really simple. We're just sending the description, which is the text box in the middle over here. And once it's sent, it also tells the browser what to do when the request is either success or failure. And so when it's success, it will automatically reload the page. So this is what this part of the JavaScript is designed for. Next up, we have the JavaScript for remove. Similarly, it's a Ajax doing a post to the delete path. We also have one that updates the status. So basically this middle part. And that is all this model.js is doing. All right, so let's move to the other two files, which is the routes and the database. And let's start from routes. So looking at this part that is being changed, the only thing that I changed is I changed the function to fetch to do. And fetch to do does something really similar to the random name that we did. But this time we're just returning a list, a static list. And this is why you will see these two entries basically the same over here. Since we defined the edit, the create, and the delete path used in the JavaScript, we're going to also correspondingly create these functions. So you'll see here, this is the delete function. And right now I have not yet written anything since we're not connected to the database. But just so that it works, I'm just going to say success, failure, and then return the result. Similar things for the edit and also the creation part. So notice that this is all dummy data. The purpose of this is to make sure that our application looks good. Our JavaScript works as intended. It's doing the refresh, as you could see from the logs, and there are no errors, which is nice. So this is working as intended. Right, so the final thing that we're going to do here is to connect the MySQL database on GCP, which is a key point of this workshop. And so the best place we should do this is by the init. So basically saying, right when the app started, please connect to the database. So how do we actually connect the database? There are two parts to it. The first part is to create all the connection information so that the app knows where to connect. And the second part is to actually write the connect function. So let's start by writing the connect function over here, which is really simple. I am going to import a few things. First of all, I am going to import OS. I'm going to also import SQL Alchemy. And finally, I am going to from YAML import load and loader. So YAML is the setting file that GCP understands. So we will be storing all our credentials and information about where to connect inside a YAML file. However, in your local development environment, it does not automatically understand that this is where all the credentials are stored. So we have to first in this init.py section detect if we are running the application on a GCP or on a local machine. So if we are running from a local machine, we will want to open the file and then read directly from the YAML file. And if not, we're just going to read directly from the operating system environment. So I'm going to say if osenviron.get GAE_env not equal standard. So this is a file that would appear on GCP, and if it's on GCP, it'll set to standard. So when it's not equal, it basically means that we are actually on a local machine, developing locally. And I'm just going to open this YAML file that we will create later and then load it into this variable. So once we have that, we will also be defining our variables in the env variable section, which you will see shortly. With all of this available, I am going to store it. Assuming we have everything in the OS environment attribute, I am going to create an engine that connects to the database. And the syntax is as simple as create engine and then defining the engine URL. So the information that we need inside this app.yaml file is the username, the password, the target database, and the host. All right. So once we have that set up, what we will need to do, okay, I have forgotten to do one thing, which is to actually wrap this entire step into so that it gets called once we have the app up and running. So I'm just going to call it init connect engine. And then I'm going to tab this entire section up here. And then I am going to return pool. Okay, so once this is up, we are going to call this function and then let this return as DB so that we can utilize this DB when we want to connect to the database. Okay, so we will work on that later, but let us set up the app.yaml file first. So I'm going to place this file next to main.py. So first of all, I'm going to define the runtime on Python 3.8, and I am going to tell it to run on an instance, the smallest possible one, which is F1. And I am going to list out my environment variables. So notice I'm just going to split screen over here so you could see this env variable refers to this section, which is namely the MySQL user. I'm going to say root and the MySQL password. And I am going to also put in the MySQL DB, which I am using the TODO database. And finally is the MySQL host, which is I'm going to place in my IP address. All right, so that is that. I am going to also add a few other things because I have it a static directory over here, the image, script, and style over here. But these should not be too much of a concern. So once I have this, my database should be ready to go. So let me just try to query this database and make sure that it works. So what I'm going to do now is I'm going to, right after this DB, I'm just going to say, I'm going to set up a connection and say db.connect. And this connection, I want to execute a SQL query. Let's just do select star from tasks table. And I'm just going to say fetch all. So this will return me all the results from this query. So I'm going to save it as results. And then I'm just going to print out the results. Let's do it in a X for X in results. So it's in the list. And finally, I'm going to close this connection. All right. Let me restart my server real fast and trigger the app. So right now, what happened is because I have not yet set the IP address and the password. So it's not getting the information. So I'll be right back and put this in and then close this window. All right, I am back. So right now I am going to restart the server. And you could see now, once I restart the server, this is the results that it is returning to me. Which is the 3 entries in the database. I could verify it by going to a MySQL workbench connected to GCP, and then again run this. It will basically return the very same result. All right, so since this database is connected successfully, I will be moving back to the database file and then updating this page and be right back. All right, I am back with the update. So here, notice I'm doing from app import DB. This DB is the same DB as mentioned in the init.py file. I'm just importing it into it. So I could do all these connections, executions, and basically doing the updates and deletes directly through SQL. And this is pretty much what the database.py does. So right now, let's go back to the application and you can see that it is working as intended. We could update the different parts and it is communicating with the database. All right, so it seems like our application is pretty much done. It's working great locally, and we want to push it to the GCP App Engine. So how do we do that? There are two things that we need to do. First of all, we need to add 2 more files that GCP App Engine needs. And we also need to set up a channel to push these files to GCP. So let me stop the server over here and add the 2 files. The 2 files are namely, the first file is gcloud ignore. So this file basically ignores the different folders and files similar to git ignore if you've used it before. And I'm just adding in PyCache folder that always get automatically generated, and the VNV, the virtual environment that we're using right now. And I am going to also ignore the .vs code. And finally, I am going to ignore this file as itself. I am going to also include the .git and .git ignore, since I will most likely be turning this repository to a Git repository. With that, I'm going to create the second file. So the second file I'm just going to generate. I'm going to do pip freeze and pipe it to requirements.txt. So this lists out all the libraries that's being consumed and used based on what we install in the virtual environment. I'm also going to delete 9 line. This line is generated because of my local Python version. But this would tell GCP what libraries it should install when we push these files to GCP. All right, so this is the first part that we want to fix. The next part would be setting up the environment. So to set up the environment, the first thing we want to do is to have gcloud available in our terminal. So the way you do it is you first install by doing curl https://sdk.cloud.google.com and pipe bash. This would allow you to start installing gcloud onto your local device. Basically, from this on, all you pretty much need to do is to press enter. I already have gcloud installed, so I'm just going to cancel it over here and to show you which gcloud, and you could verify that it's installed. And I could also do gcloud -- version. All right, so this is my gcloud and all the things that I have. I'm going to do gcloud components install app engine Python. So this allows us to push Python related code and create the app on GCP. Again, I have it installed, which you could also see over here. It is up to date. And finally, I'm just going to do a gcloud authentication login. So this would prompt out a link for you to sign into Google, and I will sign in real quick and be right back. All right, once I have logged in, you can see your logged in information over here and also what the current project is. If the current project is not set, you could also run this familiar command, which is gcloud config set project is my project ID I have on my GCP. Right, so once this is done, the final step, I'm just going to clear it first so you could see the final command is gcloud app deploy. So once I press enter, this is going to push all the files here to GCP. Because I've deployed it once before, so it's not prompting me this selection of which server I'm going to push to, but basically there will be a list of servers in different locations. You could just select one that's closest to you, and then you will see these descriptions. And I could press yes, and then it will begin the deployment. The first deployment will take quite some time. The latter ones will be slightly faster. All right, I am back. So right now you will see that it has been deployed to this website, and we could open this website. Open. And you will see the TODO app live on this given URL, and it is again connected to the database. We could also do GCP app logs tell -s default. This will bring up for log entries if we have any from the Python side. And so you will see all the logs that we used to see from Flask. So say, for example, I'm doing a remove here. So this is the remove that gets piped in. So this would be really helpful if you are debugging some issues. All right, so this pretty much wraps up what I have for the demo app. And I think this application is able to give a simple and a gentle introduction to how you use Jinja and Flask to create an application that connects front end and back end to serve a CRUD operation for a MySQL database. I think I also demonstrated how you connect the MySQL database on GCP to your local Flask system, and also how you deploy the entire application onto GCP. So do remember that whenever you finish working on your project, do remember that this app engine also incurs costs. So remember to shut down your app engine and also stop your MySQL database to save your credits. Okay, so feel free to leave any comments and questions for the TAs, and we'll be happy to help.